Laplace transform of a function t is given by integral from 0 to infinity exponent negative st ft dt. Okay, so this is the definition of Laplace transform. Okay, let's keep this in our mind. Remember, the Laplace of a small f will give you a big F. Okay, this is the transform of this is my big F with an S. So your transform equation will involve S. Okay, so the first example, maybe a complicated one. Find the Laplace transform of t squared exponent negative 2t. Okay, let's try this. Okay, so we have to find the Laplace transform. So let's do the definition first. The Laplace transform of t squared exponent negative 2t. By the definition, this is my ft now. This is my ft. So I have integral from 0 to infinity exponent negative st, and ft is t squared exponent negative 2t dt. Okay, this is just by the definition. Before you do anything, let's simplify this. So I can write this integral from 0 to infinity t squared exponent, factor out negative, and I want to write like s plus 2 t dt. Okay, so you just factor it out. Now by the integral definition of indefinite integral, so this will become limit as b approach infinity from 0 to b t squared exponent negative s plus 2t dt. Okay, so now all we gotta do is solve this integral. Okay, so I can see that you need to use integration by part for this integral here. So what we want to do, let's write it here. Maybe I'll use another pen. So we have let u equals to t squared. So we have du dt, taking the derivative, 2t. So I have du over 2t is dt. And then v equals to this part here, v. This is dv. This is u. So dv equals to exponent negative s plus 2t. We're taking, this is differentiate, this is integrate. Integrate dv gives you v, which is gives you negative s plus 2 over negative s plus 2. Okay, so don't worry about plus c or anything. We're gonna use that later on. Okay, so what we want to do here, we want to substitute our definition. So that will give you uv. Okay, so we have uv minus v du. Okay, so just continue. So we have limit b approach infinity. Okay, u, which is t squared here. So t squared, and v is this one. Exponent negative s plus 2. There's a t here, don't forget. Negative s plus 2, this is from 0 to b, because the integral we transform from 0 to infinity to this limit 0 to b, minus integral from 0 to b v du. So we have exponent negative s plus 2 t over negative s plus 2 du. What is our du here? Du is 2t dt. Okay, so we have 2t dt. Okay, so now we need to simplify this. I guess we gotta apply it one more time, integration by parts. So let's simplify this. So I have limit b approach infinity. So t squared exponent negative s plus 2t over negative s plus 2 from 0 to b. Negative take out, it will be positive. 1 over s plus 2, taking out the s plus 2, and 2. Yeah, I can take out 2. Okay, that will leave me 0 to b, exponent negative s plus 2t t dt. Okay, so now we can apply integration by part one more time here. So how we want to do it, we'll let u equals to t. So we have du dt equals to 1 and dv equals to exponent negative s plus 2t. So integrate dv gives you v exponent negative s plus ut over negative s plus 2. Okay, now I gotta apply one more time integration by part. So I have limit b approach infinity. So this is actually for the whole thing. Okay, so I have, let's write it out first. T squared exponent negative s plus 2t over negative s plus 2 from 0 to b plus 2 over s plus 2. Okay, now this one here, we're going to apply uv one more time. So we have u, so let me just write it, uv minus integrate v du. Okay, so I have limit b approach infinity, don't forget the bracket, t squared exponent negative s plus 2t over negative s plus 2, limit from 0 to b, plus 2 over s plus 2. Okay, let's apply u, which is t, and v, which is this one, exponent negative s plus 2t over negative s plus 2, limit from 0 to b, minus limit from 0 to b, v du. So we have exponent negative s plus 2t over negative s plus 2. Now du this time is dt. Okay, looks like we gotta integrate one more time to complete. Wow, that's a long work here. So I hope you're with me so far. So what we have here, limit b approach infinity. So I can actually start substituting b inside. Okay, so when t is b, I have b squared exponent negative s plus 2b over negative s plus 2. Now minus 0, but minus here, there's another minus, it will be plus. When t is 0, the whole term is 0. Okay, this is this part here. We have computed, now limit with this part. I have taking out the negative sign. Since I can take out the negative sign, I have negative limit b approach infinity 2 over s plus 2 squared. Okay, this is one term here and another term here, so it will be squared. So I have b exponent negative s plus 2b. Okay, there's nothing here. Minus 0. Minus 0 is 0, so just don't worry about that. Remember, this term here is also for this term here. So we have negative. Okay, and then what you have here, integrate this, gives you one more of this. Okay, so integrate that. So I've already factored out one term here. Bring it here. Okay, you can factor it out and bring it out. So which is this term here. So I have another one. So I have exponent negative s plus 2t over negative s plus 2. Okay, I hope you're with me. Okay, so early on what I did here, this negative s plus 2, you take it out as negative here. So minus here will be positive. Okay, minus here will be positive. And then what happened? Integrate exponent negative s plus 2t will give you exponent negative x plus ut over negative s plus 2. Okay, let's simplify. So we know that b approach infinity, this term blows out, nothing. What about this term here? You have 2 over s plus 2 squared. Limit b approach infinity. Obviously, there's a negative sign. So we have when b approach, limit b approach here. Let's just write it properly. And then we have negative here, negative, negative, and then take out the negative here. Exponent negative s plus 2b over s plus 2 plus e to the power 0 is 1. Okay, so now when limit b approach infinity, this term blows out, this term blows out. That leaves you with 1. So we have s plus 2 here. Okay, because this thing is for the whole thing. So there you go. So this is my final solution. It will be 2 over s plus 2 cubed. Okay, this is a one long solution. So what we have here, this is what we have. So the Laplace transform of t squared exponent negative 2t is given by 2 over s plus 2 cubed. Okay, so I can write that the Laplace transform of Tn exponent at is given by n factorial over s minus an plus 1 for s greater than a. Okay, so this is you can use the Laplace formula here. For instance, the Laplace of t3 exponent 3t is given by 3 factorial s minus 3 plus 1, 4. That's it. Okay, so we'll look at another example next time. Bye. Hi everyone. Today we're going to look at how to take the Laplace transform of a piecewise function. Okay, the piecewise function is given by ft equals to 0 and 2, where t equals from 0 less than 3 and t greater or equals than 3. So this is, if I have to sketch the plots of this, okay, so I have from 0 to 3, from 0 to 3 is 0, okay, and then 2, this is my 2 here, is greater than 3. Okay, so we have a piecewise function and 0 is included. Okay, so it's from 0 to 3. 3 is not included, that's why I have a circle with it's not colored or filled. And then ft is 2 greater than 3. Okay, so how do you solve this problem? How do you find the Laplace transform of a piecewise function? Okay, so recall the definition of Laplace. So the definition of Laplace transform ft is given by the integral from 0 to infinity exponent negative st ft dt. Okay, please be familiar with this definition. And then what you do here, look at this integral. Okay, so my integral from 0 to 3, so I have limit from 0 to 3 exponent negative ft, and my ft is 0. You don't have to write it, but I'm just going to write it so that you know what I'm doing. Plus, now the integral from 3, where does this go? Infinity. Okay, it go anywhere. All the way that side, right? So it's from 3 to infinity. We have exponent negative st. Now ft is 2. So multiply with 2 dt. And then the rest is how you solve a Laplace transform. Okay, so this is 0 times anything 0, so we don't have to be bothered this one. So just left with this integral here. 3 to infinity, 2 is a constant, so 2 exponent negative st dt. Okay, now to solve this integral, we apply the limit. This is indefinite integral or infinite integral. So limit b approach infinity, we have integral from 3 to b. I can bring the factor 2 out, so I have exponent negative st dt. Okay, now I can solve this pretty easy. So we have 2 limit b approach infinity. Now integrate this, will give you exponent negative st over negative s, and the limit is from 3 to b. Okay, so I have 2 limit b approach infinity. So exponent negative s when t is b minus when t is 3, exponent negative s3, this is bad way to write 3s instead. So 3s over negative s. Okay, now we gotta apply the limit and we should be done. So let's see what we get. The solution is when b approach infinity here, this term tends to 0. Okay, but there's no b here, so that gives me 2 limit b approach. I'm taking the limit, so I don't have to write the limit anymore because I already applied the limit. So I have 0, negative, negative, positive, exponent negative 3s over s. Are you with me? Okay, so simplifying, I have 2 over s exponent negative 3s. And this is true if its s is greater than 0. There you go. This is how you apply a limit of a piecewise function. Okay, so try this homework. So the homework for you is find the Laplace transform when ft is equals to sine t, where t is equal from 0 less than pi, and 0, where t is greater or equal than pi. Okay, so this is your homework. So maybe I can write the answer so that you can check your solution later on. The answer should be exponent negative pi s plus 1 over s squared plus 1. Okay, this is the answer. Okay, this is your homework. Okay, so let's summarize what we have learned. All these Laplace transform in a form of a table. Okay, so we have obtained few Laplace transform. So I will call this the Laplace transform table. Okay, so you don't have to solve the integral all the time. If you have the table, you can actually check it out. Okay, so this will be big F, Laplace of this. Okay, so which is given by 0 to infinity exponent negative st ft dt. Okay, so if you are given 1, the Laplace of 1 is 1 over s for s greater than 0. The Laplace of t to the power of n is given by n factorial over sn plus 1 for s greater than 0. The Laplace transform of exponent at is given by 1 over s minus a for s greater than a. And then we have the cos and sine, the Laplace of cos and sine. So we have the Laplace of sine kt is given by k over s squared plus k squared for s greater than 0. And then the Laplace of cos kt is given by s over s squared plus k squared for s greater than 0. And then we can have a combination of exponent and sine, where the exponent at sine kt, the Laplace transform is given by k over s minus a squared plus k squared for s greater than a. And then we can have, for the cos, exponent at cos kt is given by s minus a over s minus a squared plus k squared for s greater than a. Obviously, we can have so many of the simplified version of this Laplace transform. I want to write one last, which is the one we look at on the previous video. Tn exponent at is given by n factorial over s minus a n plus 1 for s greater than a. Okay, these are some of the Laplace transform. Okay, so I'll show you one or two from this transform. One example, one of two of these. So let's look at. So what I mean by this simplification of this transform is this. So let's say I'm given the Laplace of et cos t. Okay, so from this table, look at this table here. So I don't have to integrate now. So I just compare. So I know that my a is 1. So I have s minus 1 over s minus 1 squared plus k squared. What is k here? K is also 1. Right? K here, k is also 1. So this is 1 squared. So this is how you simplify without using the integral definition. Okay, now we can also have other simplification from the table. For instance, let's look at one more example. So how to find? So let's say evaluate the Laplace transform of half et plus e negative t. Okay, so if you have a question like this given, you can actually use some of this nice Laplace property. Okay, so don't have to use the integral. So what you do here, so the Laplace of half is a constant, so you can bring it out. So all you gotta do is Laplace of et plus half Laplace of exponent negative t. Do you see what I did? This half is for both, so I can take out. Okay, so what I give you here, this is half. Now Laplace of exponent t from the table. So we have this table here, exponent t when a is 1. I have 1 over s minus 1. Okay, so this table is very handy. So I have 1 over s minus 1. And then plus half of, now Laplace of exponent negative t when a is negative 1. So look at your table again. When a is negative 1, I have 1 over s plus 1. So we have 1 over s plus 1. So therefore, my Laplace transform is given by half 1 over s plus 1 minus 1. Or you can write the other way around, that's okay. So we have 1 over s minus 1 plus 1 over s plus 1. Okay, that's your final answer. So we have few more minutes. Now let's say evaluate. Okay, so evaluate, maybe this can be your homework. The Laplace transform of 3t minus 5 sine 2t. Okay, so you can use the table pretty much easily to solve this. So I'll put it as an homework for you. Okay, so if you have a constant, you can bring the constant outside this Laplace symbol here and then refer to the table. Okay, refer to the Laplace table. You can also use the definition of integral if you want. It's just going to be a long working. Okay, so that's all. So I'll see you in my next video. Thank you. Bye.